Welcome back, Geometry Advanced. We are going to continue going through the review guide solutions. So we need to pick back up with number 23. All right, so let's talk about 23 real quick. I wrote up 6 ways, not just 5, but 6 ways that we could show a quadrilateral is a parallelogram. Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. The diagonals bisect each other. Any 2 consecutive angles are supplementary. And then the other way that we did talk about briefly was to have one pair of opposite sides both parallel and congruent at the same time. Okay, so if you did not get all 5 or at least 5 ways to prove that, make sure you get those copied down. You can pause the video if you need more time with those. I might be erasing some of that to show my work for 24 and 25. All right, 24, classify the quadrilateral, then find the values of x and y. So we know we have a quadrilateral. Because they marked opposite sides as being congruent to each other, we know it's a parallelogram. Because all 4 sides are congruent and all 4 angles are right angles, that is enough to tell us that this is a square. When we go to find x and y, make sure you're paying attention to what kind of information you are given. Right now, the expressions involving x and y are on the sides, meaning they are not degrees, they are not angles, they are on the sides. When they are marked on the sides, you are not going to use things like 90, 180, 360. 90, 180, 360 are all angles. Right now, these are sides. Okay, when we move on to 25, there they marked angles. Here we have sides. Make sure that you're keeping that straight because I still see some people confusing those. Because all of the sides are equal to each other, we could set any 2 of them equal to each other. To make this easy on myself, I'm going to set these 2 equal to each other that both involve x. 5x minus 4 equals 3x. Subtract 3x on both sides, add 4 on both sides. That gives me 2x equals 4, so x equals 2. Okay, a couple different ways you could go about this. Now that you know what x is, you could plug x in and find a side length. So for example, we know that any side length then should be 6. 3 times 2 is 6. So I could take either of these expressions and set it equal to 6 to find y. Or you could set these 2 expressions equal to each other to find y. It does not matter to me as long as you showed me some work. So I'll do 5y plus 1 equals 6. 5y would be 5, y would equal 1. I do expect that you are going to show me some sort of work. It might not be exactly the same as mine, but it should be mathematically sound, and you should get the same value for y. All right, let's move on to 25. On 25, again, we have opposite sides congruent, so this is a parallelogram. Because all 4 sides are congruent, it is going to be a rhombus. It is not a square or a rectangle because we do not have 90-degree angles. Oh, I'm going to have to scroll because it's a little hard to see. So let's scroll before we continue that one. Just a little bit. All right. We said this is a rhombus. So in order to find x, we are using angles. In order to find y, we're using sides. I'll show my work over where 24 was. Let's find x first. These two angles are consecutive angles, which means in a parallelogram they must be supplementary. So 2x plus 1 plus 127. Ooh, sorry, that's a 2x minus 1. Let's back it up. 2x minus 1 plus 127 is equal to 180. Okay, you can combine your like terms. And then you can subtract on both sides. 2x equals 54. And then divide by 2, x is equal to 27. All right, x was pretty easy. Let's find y. Kind of like on the last problem, if all the sides are congruent, then these two have to be congruent to each other. Let's show that down here. If they're congruent to each other, we can set them equal to each other. 6y minus 5 equals 3y plus 7. Okay, get all your y's together, get all your constants together. That gives us 3y is equal to 12. When we divide, y is equal to 4. You could check yourself by plugging 4 back in here, and you know that those two values should end up being congruent or equal. Okay, if you've got questions, concerns about 25, write them down, send me an email, a comment, something. I'm going to scroll down to 26 and 27. All right, on 26, we've got a figure that we haven't necessarily worked with quite as much, or at least not quite as long. This is not a parallelogram because opposite sides are not congruent to each other. However, since you have two pairs of adjacent sides congruent to each other, it is a kite. All right, so we need to work on finding x and y. In my opinion, y is easier in this case. Anytime you have a kite, one of its properties is that you have one pair of opposite angles congruent. Ooh. So if you heard what sounded like a cat meowing, that was my phone ringing with the school district calling to let us know that e-learning is continuing on. So back to 26, we have a kite. I was going to say that finding y is going to be easier because we've got a pair of opposite angles congruent in a kite, but only one pair. And it's the pair that occurs between a pair of non-congruent sides. So these two sides here are not congruent. That angle is congruent to the other angle between two non-congruent sides over here. Okay, so y has to be 88. All right, finding the last angle is not too terrible because this is a quadrilateral, and inside a quadrilateral, all the angles add up to 360. So we just need to take 360 and subtract off all those other angles, all three of them. So minus 120, minus 88, minus the other 88. All right, when we do that, we should get 64. So x would be 64. Make sure you do not fall into the trap of thinking that you have any supplementary angles here. That is not necessarily true inside of a kite. That is only used inside of a parallelogram. So if you were trying to use 180 anywhere in this problem, you were incorrect. Okay, it's got to be from 360. Let's move on to number 27. 27, we know we have a parallelogram because we have opposite angles congruent. And all of those angles happen to be right angles, which would make this a rectangle. We do not know anything about any of the sides being congruent except for the fact that opposite sides would be congruent. So we cannot say that this is a rhombus or a square. We don't know that. All right, this one gets a little trickier as far as showing your work goes. So let's start off by just talking about it. I'll see if I can make enough space here to show my work. All right. We know it's a rectangle, it's a parallelogram, therefore opposite sides do need to be congruent to each other. That means that 5x plus 4y needs to equal 3. Negative 5x plus 4y needs to equal 3. We can't solve that because we've still got two variables in it, so that's not super useful right now. But we do also know that the other opposite sides are congruent. So negative 3x plus 5 is equal to y. In order to do this, we need to solve a system of equations. So you get to choose kind of how you do this. One thing I would recommend for sure is that we get this bottom one in standard form, which means I'm going to subtract y on both sides and subtract 5 on both sides. So this bottom one is really going to become negative 3x minus y equals negative 5. I just rearranged it. For me personally, to solve this system, I think I would like to use elimination. And I'm going to work on eliminating my y. So if I want to eliminate y, I could multiply this whole bottom equation by 4. So I'm going to rewrite my two equations that I'm using now. I'm using negative 5x plus 4y equals 3 from the top there. Didn't change it. And I'm going to multiply this whole bottom equation by a 4. That gives me negative 12x minus 4y equals negative 20. When we combine those two equations together, the y's are going to eliminate. That was my whole point here. Those eliminate, cancel out. Everything else combines down the columns. So when we combine, we get negative 17x equals negative 17. So of course x would equal positive 1. Fill that in for part of my answer. All right, once we have x, it's pretty easy to find y. We just need to plug it back in. So I don't care which one you plug it into. In my opinion, it's easiest to plug it in to 3x plus 5 because initially we had set that equal to y. So if I go back to that, negative 3x plus 5 had been set equal to y. So if I plug in my 1 for x, it's going to give me y right away. Negative 3 plus 5 would give me 2. Kind of hard to see that. I'll bring it down to the bottom here. So 2 would be equal to y. 2. Okay. If you have questions remaining about that problem, please let me know. Again, we were dealing with sides, not angles. If you set any of these equal to 90, 180, 360, you are not doing it right. 90, 180, 360 are angles, not sides. All right, so enough of that page. Let's keep scrolling down. We are told that MN is the mid-segment of these trapezoids. Remember, a mid-segment of a trapezoid connects the midpoints of the two legs. Those are congruent. Those are congruent. But maybe more importantly, we know how to find the mid-segment. I'll put that formula up towards the top here. The mid-segment is equal to half the sum of the bases. So in this case, x is the midsegment, so x is equal to half the sum of the bases. The bases are 21 and 17. So then you just need to do some simplifying, order of operations. Half of 38 is 19. That is our value for x. All right, on 29, we're going to use the same formula that I'd put up at the top. However, it's going to work a little bit different. Still start off by plugging in what you know. This time the mid-segment was labeled 32. So 32 is equal to 1/2 of, we need to add our bases together. This time our bases are 4x and 43. So 4x plus 43, or you could put it as 43 plus 4x, that's fine. You could distribute the 1/2, but in my personal opinion, it's going to be easier if we just multiply both sides by 2 right away. If you multiply the left side by 2, you would get 64. On the right side, when you multiply by 2, it just cancels out with the 1/2. So you're left with 4x plus 43. All right, to keep this going, we need to subtract 43 on both sides. And 64 minus 43 is going to give us 21. To get x all alone, we would have to divide by 4. I would be fine if you left it as 21 over 4, or if you really want to put it as a decimal, 21 over 4 would be 5.25. Don't round it. You should either give me the improper fraction or the full decimal answer. All right, so that is it for 29. Let's move on to 30 through 33. I had a lot of people ask me questions about this as well. The diagonals of a rectangle, so that's important, this is a rectangle, intersect at P given that angle YXZ. So let's find that angle, YXZ. So that's this little angle right here, is 50 degrees. And XZ, so that's this diagonal here. XZ has a length of 12. Find the indicated measures. All right, first up, WXZ. So from WX, then down to Z. So that's this little angle here. Well, that shouldn't be too hard to find. What do you know about the big angles in the corners of a rectangle? They're right angles. So this needs to be a right angle altogether, which means this little angle that I'm looking for right now needs to be complementary to the 50-degree angle we marked. They need to add up to 90. So hopefully you have decided that that angle should be 40 degrees. All right, let's move on to 31. Okay, 31 I could see as being a little bit trickier. We're looking for angle WPX now. So let me take this away. We've got these two angles now. Now we're looking for WPX here in the middle. All right, so in order to do this, one thing you should remember is that in a rectangle, the diagonals bisect each other because it's a parallelogram. The diagonals are also congruent to each other inside any rectangle. So since the diagonals are congruent and they bisect each other, that means that each little piece of every diagonal is congruent. Okay, so for example, if, just hypothetically, ZX was 10, that would mean WY is also 10. They bisect each other. Each little piece is equal to 5. I don't think that's the case on this problem, but that's how this works. This means that we have formed isosceles triangles. This little triangle is isosceles. One thing we know about isosceles triangles are that the base angles or the angles across from the congruent sides are congruent, which means this is also a 40-degree angle. Now, if we again bring back that little triangle we'd highlighted, if we know two angles in a triangle, you can always find the third one because all the angles in a triangle add up to 180. So if we take 180 minus 40, we would get 100, and that is the measure of angle WPX. Okay? Now, having talked through all of that, that should make this last part pretty easy. We are trying to find nope, not yet. We're trying to find PY. PY is a piece of a diagonal. In the directions, they told us that XZ had a length of 12. Okay, so if we split that up, that would mean that PZ and PX both have a length of 6. And we already talked about the fact that every single piece of each diagonal needs to be congruent. So PY would also be 6. All right, last up we are asked to find the length of WX. So I'm going to clean up our diagram real quick so that we can talk about WX. Okay, I cleaned up the diagram, but I also went ahead and just drew part of the diagram off to the side so that we can focus on what we know. We know that we're looking for WX, so if you wanted to mark that with a question mark or a variable, I'm going to mark it with A. Why not? Just an A. All right, the angle at W, since I don't have that diagonal drawn in, that is a 90-degree angle here. And this little angle up here, WXZ, we already found that that angle was 40 degrees. So looking at this, I'm going to say we have to go back to using our right triangle trigonometry in order to find this missing side. That's the way that stands out to me. So if we look at this angle 40 degrees here that we know, we have the adjacent side and we have the hypotenuse. Which trig function used adjacent and hypotenuse? Hopefully you're telling me cosine. So I'll write that over here. The cosine of 40 degrees is equal to A over 12. To get A alone, we cross multiply. A is equal to 12 times the cosine of 40 degrees. You just need to get your handy dandy calculators out to help you with that calculation. All right, and if we round that to the nearest tenth, I'm getting it to come out as 9.2. So we could make that approximately 9.2. Okay, if you've got questions, concerns about that, please let me know. I know that that is a little bit of a throwback to that trig chapter we haven't talked about in a while. I'm going to move on. All right, 34. We're given some points of a quadrilateral. Give the most specific name for it and justify your answer. All right, so I went ahead and plotted my points. A, B, C, and D here. All right, so it looks like this is probably a parallelogram. Maybe it could be a rectangle, but we would need to prove those things. And I think the easiest way to do that, or at least to start it, is going to be to find our slopes. Slopes will not only tell us if we have pairs of parallel lines, it will also tell us if these lines are perpendicular to each other, which would mean that we would have right angles. So I am going to pause this while I write out the work finding the slope for each one of these lines. All right, here I have shown all of the slopes. So I just went around the quadrilateral, AB, then BC, then CD, then DA. Found all my slopes. So this tells me that this is a parallelogram because the slope of AB and CD were the same. They were both 2. That means those are parallel. So I'll mark that with my little triangles. Okay, these 2 are parallel. Same thing goes for BC and DA. They had the same slope of -1/2. So those are parallel to each other. So we know it's a parallelogram. Then we have to decide, can we get more specific than that? Well, I believe the answer is yes. If you look at your slopes of 2 lines that are next to each other, like AB and BC, those slopes are opposite reciprocals, meaning that AB is perpendicular to BC, and we can go around and make those statements all the way around. BC is perpendicular to CD, CD is perpendicular to DA, DA is perpendicular all the way back up to AB. What that means is that these are all right angles. I know my diagram's getting a little crowded here, but because we have a parallelogram with 4 right angles, that's going to make this a rectangle. Now, the last thing that we should technically check is to make sure that this is not a square. Okay, we don't necessarily need to find all the distances, right? The distance of AB is not going to be the same as the distance of AD. So I would rule out a square right away. So rectangle because opposite sides are parallel, okay, which we can see from the slopes. And you could say consecutive sides are perpendicular, or just that you have perpendicular lines so it forms right angles. Something along those lines. I would need to see all of your slopes to know that, though. So you would have to show me all your slope calculations in order to use this as a justification. Okay, that gave us right angles. All right, so I believe that's the end of this video. Let's scroll down and take a look at it. The rest of this really should have come straight out of your notes. So I'm not going to go through this whole slide. You should be able to look back in your notes to find all of those answers. All right, so a heads up about tomorrow. Tomorrow is Friday. We are at the end of chapter 8. We are going to take a version of a test for chapter 8. It's going to be different from what you've done before. It will be multiple choice. You will fill out a Google form for it. Now, initially when we started e-learning, the plan was not to do quizzes and tests. However, since we are now going to be in this for at least another month, we are going to be doing some quizzes and tests. They will not be as long as they would normally be in class. Also, they will not be worth as many points. Okay, I know this is all different. You're doing it on your own from home. I'm not there. I can't clarify things. So it will be called a quiz or a test. However, it's not going to be exactly like when we had quizzes and tests in class. If you have questions about that, send me an email and I will talk to you guys later.